Hello YouTube, and thank you for watching. Today I want to talk about an execution plan using a real-world example. Recently I had a developer request assistance with a view that was taking over 5 minutes to complete. This particular view joined on 6 tables with a few filters at the bottom. It's a rather complex query, typical in a production environment. The first thing that you need to do is to look at the execution plan, and the way to do that is to run this statement: alter session, set statistics level equal to all. This will trigger Oracle to gather the actual execution time, the amount of buffers, and the disk reads as it performs the select statement. The next thing you do is to run the actual select statement and then get the actual execution plan. Not the estimated, but the actual execution plan. Now, for those of you that may not know what this is or how to go about it, Maria Colgan has published a great article. She is a senior product manager over at Oracle, and this page has a wealth of information regarding all these procedures. She also has a number of YouTube videos which I find very helpful in training. I myself have spent about 6 months studying this material in order to get myself familiarized, so it's not an easy task, but if you stick with it, you'll become an expert at it. Now there's two ways to get the actual execution plan after the query has been executed. You can either run this with a null value immediately following the select statement, and what this does is it'll fetch the execution plan for the last statement that was executed in your session. Typically you use the second method, which will require you to get the SQL ID and the child number. And the way to get that is to query the v.SQL view, and I'll post this query in the description. Now the particular slow query execution was fetched, and this is what it looked like. For those of you that are wondering what this is, I myself don't do this regularly. I think the last time I tuned the query was about 6 months ago, so it is a bit overwhelming when you first take a look at it. But there are ways to dissect this so that it makes sense. The first thing you do is to look at the actual statistics columns, which are indicated by the A rows, the A time, the actual buffers, and the actual disk reads that was performed. Now in this case, what you want to do is look at the actual runtime. So you can see that the query completed in 5 minutes and 2 seconds. And if you scroll down to the bottom here, what you'll notice is that this particular line pretty much took the entire execution time of 4 minutes and 55 seconds. So if you scroll over to the left over here, what you'll see is the object name. In this case, the table is transfer, and the operation that it performed was table access by index row ID. I call this key lookup, and what it is essentially Oracle is looking at the index, finding the row ID. Now what it does is it has to go to the table and then fetch the additional columns that were requested by the query. So for each row that it finds in the index, it goes to the table, fetches the columns, comes back, and does this over and over and over again. Obviously for one or two queries, one or two rows, it's not a big deal. When you're doing this for millions, if not billions of rows, this can be very expensive and very slow. And that is what is happening here. It's taking almost 5 minutes to complete this action. The solution is pretty simple for key lookup, and that is to create a covering index So the covering index will contain all the additional columns, and that way the index has all the columns that are requested in the query. So there's no back and forth going to the table to fetch the additional columns. After the covering index was created, you can see that the total execution time reduced from 5 minutes and 2 seconds to 21 seconds, which is much more tolerable. And if you go down to the line over here, the covering index was created, which included all the columns that were requested by the query, and the runtime had reduced from 4 minutes 55 seconds to just under 21 seconds. I hope you liked this video. If you do, please hit the like button and subscribe for more videos. Thank you.